Hi everyone, this video is kind of the last in a little series of videos about computers and audio and microphones and the physics of sound and all of that kind of stuff. So what this particular video in this series is going to be on is just how computers interact with audio. In the last video I talked about what a microphone is, how they work. They send out that electrical current that's represented by the sound. You can do different things with it. Um, Before that, I talked about just the physics of sound and how that works. So we're going from there. I may re-record this later. I'm in the process of getting a new camera, um, better setup. So if you see another version of this out there, that's probably going to be the difference. But right now, we're just going to go on like this. So computer audio. Um, it's not as complex as you might think it is once you understand what's going on. So in the last video, I mentioned that um, the microphones here, these guys, when you talk into them, it converts the vibrations into a continuous stream of electricity, and it sends those out the little prongs in the back of your microphone. Um, Now you can connect these to computers. Sometimes you'll have a microphone that has a USB connection on the back, and you can just plug that right into your computer. Sometimes you'll have a little box like this that you can connect your microphone cables to, and then on the back there's a spot to plug it into the computer, stuff like that. Either of those are fine. It kind of depends on what you're using. For my students, when I teach this course, I usually bring in one or two just little small devices like this, uh, just to kind of help supplement what the school has um, with there. But they both work essentially the same way. All right. So a computer works in numbers. All right. That's the kind of the key thing to start with. All right. The computer cannot receive this constant stream of electricity that the microphones are putting out. It has to be converted into some kind of number. Um, all right. So this is what's called a digital versus an analog signal. This electricity, this constant stream of changing electricity, that's an analog signal. Whereas a constant stream of numbers, these are kind of discrete one is one, three is three, and so on and so on. That's a digital signal. All right. So again, you can computers will generally have built onboard, or they can be connected to a device, a little circuit board that has what's called a analog to digital converter. And what this does, this will take the incoming signals from your microphone, and it essentially just takes a snapshot of that signal and says, at this time, the signal was 3. And then a little bit later, now the signal is 2.9. Now the signal is -5. Whatever. Those are, if you actually get those numbers, you have bigger problems. But I just kind of picked them out of the hat. But essentially, the computer converts it, and it can either save those numbers in the computer's memory as a file. It can just transport them out and use that to power a speaker automatically. You can do all kinds of stuff, just like with the signal that I'll talk about in a second. All right. There are two important things that you should know about um, when working in these with this computer audio. The first of which is the sample rate. All right. So I mentioned before that the computer is taking a snapshot of this electricity, and it's saying, "Hey, now we're here. Now we're here. Now we're here. Now we're here." The computer's just doing that continually for as long as it's running this audio recording or processing or whatever it's doing. Um, the speed at which this happens is the sample rate. All right. Kind of the standard sample rate for, if you ever listen to a CD, is 44,100 times every second. There's math behind why it's that high. We don't need to get into it right now. But essentially, the higher the sample rate, the better quality audio. If you think about it, if you don't have a ton of samples, you're gonna get kind of jumpy audio, and it's going to be kind of lower quality sound, kind of distorted, because it's going to be the sound may have changed more quickly than the computer could have taken that sample. So again, 44.1 is the standard kind of CD quality. 48,000 is kind of high definition audio. In very rare cases, I've seen something set up as high as 96,000. But again, most of the time it's 44.1 or 48K for the sample rate. Now, compared to other ways of doing like if you're taking a picture or something, this can cause sound files to be surprisingly large, unless you've done some kind of cutting down or compressing of them. Because again, if you have a file that is an audio recording that's 1 second long, well, that's 44,100 different discrete numbers in this file. So if you have something that's 3.5 minutes, that's 3.5 times 44,100. That's a lot of different numbers in a particular sequence. So most of the time, though, this isn't really an issue. Modern computers can store most of this stuff relatively easily. I just wanted to mention that compared to other things you may have worked with, these may be bigger files. All right. So bit depth. Bit depth is the other side to sample rates that's important to think about when taking these snapshots of this audio signal. I mentioned it takes a snapshot of it, and the computer says, all right, at time marker 00, we're at this point. At 0.01, we're over here. And now we're up to this point. What those points are is the bit depth, all right? It's essentially almost like the resolution of the photos. The higher the bit depth, the more exact the computer can set those points. Because it's just going to essentially pick the closest one. So if the audio voltage is 0.5, but the closest bit depth is 0.48, it's going to set it, save it as 0.48, and so on and so on. So again, having a higher bit depth, again, it'll cause a larger file size, but it gets a higher definition audio. Again, standard is 16. You can go up from that. These bits, essentially, the bigger the bit, the better the audio. And having lower bit depths can result in kind of these distorted and choppy sounds, just like having a lower sample rate can distort these sounds as well. All right, so I got a diagram here kind of showing that. So this is a sound wave here going in, and we start at 0, and each of these little blue dots is a sample. And as we move here, we start off at -4, and here at the next one we're at 0, we're at 4, and then the sound wave goes here, but it's not quite. It's closer to 7 than it is to 6, so the computer is going to put that to 7, and it's going to keep going to the next sample. That's right at 6, the next sample at 3, and so on and so on. If you work in Audacity and load in a sound file and zoom way in, you'll see something very similar to this. So again, the sample rate is how many of these blue dots appear every second when you're recording sound. And the bit depth is the number of possible little divisions that you can assign these samples to. So again, having higher of both makes higher quality audio, but it makes your file sizes much larger. All right. So saving these, again, this is just a series of numbers. These can be saved to computer memories. Not you, Siri. These can be saved as sound files either to the computer memory. If you use a handheld recorder, kind of like this one, which you will be in the digital storytelling class, they'll have a, let me pull this one out, a little memory card in there that, it's just a string of numbers essentially in the computer memory. And it'll save them to here, so you can stick the save them in the memory card, move them to other things, do stuff like that. You can apply algorithms to these and manipulate the numbers and the order of numbers in order to apply digital audio effects um, to it. And then this number uh, can eventually be sent to a digital to analog converter, the opposite of the analog to digital converter, and essentially be changed into a voltage, a string of electricity that can then go and power a speaker in order to output the sound wave. Um, so that's there. These sound files, um, again, as I mentioned, it's essentially just a bunch of numbers. At this point, you'll notice that there are different files, different ways to work with the sound. The most common that we will have in our classes will be a .wave file. This is just the pure audio sound. These files tend to be a little more high def than something like an MP3, but they're also much bigger because it's just the pure audio data. Things like MP3s are usually a little bit lesser in quality, but they're much smaller in size as well. So they're much easier to send to other people or to use in certain programs. And essentially, the way this has happened is any frequencies that are higher than the human range of hearing, anything above that 20,000 hertz just gets cut out of the file, and it just gets automatically just erased from the computer memory. So it's a much smaller file. Now, there are other file formats as well, and I listed a few on the slide here. I'm not going to go into all of them, um, but generally speaking, WAV and MP3 are your best friends. They can be played on just about any device out there. Um, so whenever you're exporting audio files from your software, or when you're recording things in your handheld device, you can choose the file format. Choose either WAV or MP3, and you'll be good to go. All right. So I mentioned the handheld recorders. We'll be having all of those. I actually have this. If I remember, this isn't the one that we're using, but this is the same brand, very similar. All little handheld recorders are very similar. They vary in quality. Again, they all have the same components, whether it be there's a microphone usually at the top. There's some kind of screen for interfacing usually. And then there's an SD card that you stick in there in order to save the data. And then you can play back these recordings, but usually the speakers are very low quality because, again, it's just a little handheld device that can't be very good in big speakers. So you can do all of that. And there's usually some kind of navigation buttons, as we see here on this one. This one has two microphones, so it can do stereo, a screen to go through things, buttons for navigating through the menus if needed. The record button is always very easy to find, so you hit record. So you point it at your thing, you hit record, and then it records, and you press it again to stop. And there you go. And then you can either usually connect it with a USB or just take out the SD card and plug it into your computer, and there you go. If you're doing any of this at home, you'll be able to do this on your phone and whatever other devices you might have. That'll vary from device to device, so I'll probably make a separate video just on how to do this kind of thing with a phone. But those are all very similar. It's essentially the same thing. You pull open the recording app that you're going to use, voice memos or something like that, and then just hit the record button, talk into the microphone on your device, hit the stop button, and there you have the file, and you can share it however you would want to. All right. So our recorders, we have the Tascam DR05X handheld recorders, and that picture at the top of the screen is the exact one one of the ones we have at the STEM Center. We got 4 of those we'll be able to share for the class. Again, your personal devices you could use for some of these things, and then there's some microphones built into the laptops, but they aren't very good. So you have all of that. Whenever I teach these kinds of courses, I usually bring in some of my own personal sound equipment um, that can be borrowed during the class. Um, and that'll be a few microphones, usually three dynamics, two condensers, and all this can be adjusted as needed. Um, the microphone cables necessary for that, and if anyone uses those, I'll show you how to wrap those. Um, the little sound interfaces to use the microphones with. So this guy, um, that, and then a my nicer handheld recorder, which again I've got a little picture of right there, a Zoom H5, um, which again is very similar to the Tascam here. It's just slightly different. It does a few more things, but it in the core it's pretty much the same thing. So pretty much, yeah, that's what we have and we'll be using, and I'll have kind of a how-to video on all of that stuff later. I'm not going to spend a ton of time on this slide. Um, this here is essentially what I was saying before. You insert your SD card into the device. Um, if you're going to work it in handheld mode, they got to have batteries. Um, if not, there's usually on our particular ones, you can connect it via USB to the computer. Um, and ours actually have a cool feature. When you do that, you can use it as an external microphone in our audio program. And I'll talk about more of that in a later video. But when you do that kind of thing, all the controls are handled on the computer, not on the device. But when you're just using it portably in this handheld mode, um, once you've put in your memory card to save your recordings, you turn it on, you find the power button, hit the power button, you point, point the capsule of the microphone at what you want to record. Again, these will be at the top of the device. Because again, like I was saying, if you're going to talk into your microphone like this, you're not going to get a good recording. You want to talk directly into the capsule of the microphone to get a good sound recording. So point it at what you want to record, hit the button, and then hit the button again to stop. You can navigate through the menu and play it back on the speaker if you want. You can also plug in headphones and do that, or you can just move it to the computer and listen to it there. All right, that's essentially it for content. For kind of just the nitty gritty. What is this stuff? In the unit of digital storytelling, the projects that we're going to do, kind of using this, we'll be creating a various kind of library of sound samples. So each person will make, I haven't decided yet, 3 to 5 short little sound effects samples that for other projects, anyone in the class can then use. Shouldn't take too long, and that'll help us get used to working in Audacity. The next thing will be a soundscape. And again, a 30 to 60 second sound environment that's going to tell some kind of narrative. However, there's going to be only atmospheric sounds, no words, no music, anything like that, just the various sound effects. And we'll talk a little bit about what goes into that in class, but that's what we can look forward to there. The last project in this sound unit is what's the radio drama. And essentially, this will be a group project, and you'll be creating a 5-minute radio drama. This is essentially a tiny little soap opera almost. You're telling a story of some kind. You have no visual aspect, only words, only maybe a little bit of background music is necessary, sound effects, things like that, but no visuals whatsoever. And for fun, you also have to throw in a commercial break, but I'll talk about that again in more detail when we get to each of those. It's just for any of my students in the digital storytelling, using what we've gone over with what is sound, how does a microphone work, how do the computers save the audio, use that in order to do these things. We'll get practice with all of this through these 3 little projects. So just like before, if you have any questions about any of that, feel free to put a comment in the video and I will respond, answer those questions. again, keep an eye out. I'll probably reshoot some of this, maybe touch up the PowerPoint a little bit when the new camera gets here and I'm not stuck with the built-in webcam on my monitor that's 3 feet away and 20 degrees up from my head, just to make everything a little bit easier. So